Hello and welcome back to Physical Geology. Today I want to how to use the Google Earth applications that we'll be using in this class for homework assignments and lab assignments. So again, we're going to work through our Canvas homepage, and what you're required to do is to download Google Earth onto your computer. Many of you probably already have it, but let's show you how we're going to do this. So in Canvas, you'll want to go to obviously to our course, and under modules you'll see that at the top here I have the syllabus and course materials. You'll see that I have some Google Earth resources here. So you click on that, and then this should take you to an instruction page on how to download Google Earth. If you already have Google Earth on your computer, then I would recommend to download these Geo Tour files. We'll have these assignments in the Google Geo Tours workbook, which are really going to be supplied through our Canvas webpage, and you'll want to download this file. So when you click on that, it should take you to a KMZ file, and you want to you probably want to open it with Google Earth, although I already downloaded it on my computer, but let's see what happens here. So so once Google Earth opens, you'll see that in my places, you'll see this Geo Tours folder that comes up here, right? The Geo Tours KMZ file, and you'll want to open that up to see what's in here, right? So under the Geo Tours KMZ file, we'll have the Geo Tours. You can read the welcoming and getting started, and but we really want to go to these Geo Tour worksheets, and the first thing we want to do is Earth and Sky. But before we click on anything to make it active, let's go and read the directions that are in our Canvas. So to go to modules, note that under chapter 1 that there's a Geo Tour worksheet, Earth and Sky. Geo Tour worksheet, Earth and Sky, and this is going to be a quiz, right? So you want to be prepared for this. So when we click on this, you'll want to take the quiz. I'm the editor, so I'm going to preview it here, but I'll take it as we go along here. 12 questions altogether here. So to answer the questions, please install Google Earth and run the Geo Tour files. And so here there's more instructions how to do it. It even gives you the KMZ file right in here as well, so you can have access to it there. To answer the questions, go to the Geo Tours folder in Google Earth. 2, exploring geology using Google Earth Geo Tours worksheets, and then A, Earth and Sky. So select Google Sky by clicking and then selecting Sky. Turn the Sky database's imagery in the layers panel, double click place mark problems 1 in A, Earth and Sky in the folder. So let's do that first. So they want us to click on this Earth and Sky right here. Let's open it up so you can see there's a few problems related to Earth and Sky here. And so we'll open that up, and then the other thing it wanted us to do is to select the sky. So up here at the top you'll see a Saturn up here. So click on Saturn, and then we want to do sky, right? So this is going to show us the heavens, right? Then it says double click on problem 1. So let's click on this problem 1. And it talks about this. The Grab Nebula is a supernova event, and so it's a cataclysmic implosion of a star, right? That happened in 1054 Common Era. And this Crab Nebula, we're going to try to answer some questions regarding this nebula. So if we go back to our quiz in Canvas, so the Crab Nebula is located about 6,000 light years from Earth, and the present length of its long axis is approximately 11 light years, right? So that's about 11 light years. In other words, it takes 11 years for light to travel from one end to the other end. Continuing on here, so 1 light year is 9.5 trillion kilometers. So here they want to know the length of the long axis of the Crab Nebula in kilometers. So to do that, we're going to have to do a little bit of calculations with our calculator here. So we have 11 light years times the 9.5 trillion kilometers gives us 104.5 trillion kilometers. So there it is right there. And so we'll go on to the next question. Again, to answer this one, we want to go with the same instructions, and then in this case, it also is asking us about the Crab Nebula. It's a supernova explosion of once massive stars, which was likely a third, fourth, or even later generation stars. So one of the things we know about stars is that stars have a life cycle, and the very large, enormous stars that are 10, 20, 100 times bigger than our sun use their hydrogen so vigorously that they have very short life cycles, right? So, the end of the star will for the large stars involves a supernova event. Our star is a medium-sized to smaller star, and it will not go supernova. It'll become a red giant. But anyways, one of the things that happens in a supernova event is that atoms heavier than iron, which is atomic number 26, right? Iron is atomic number 26. Atoms heavier than iron are formed. So like uranium, lead, silver, those are formed in the supernova. Remember, anything lighter than or up to iron, which includes carbon, oxygen, calcium, iron, those are formed inside of stars through nuclear fusion, right? So that's how the heavy elements are formed. And I'll mention that in one of my lectures here. So the question is, heavy elements with atomic weights larger than 26 are likely generated during this explosion, supernova event. Which element is probably formed in the supernova? And so obviously carbon, hydrogen, and helium, those are very light. Carbon is formed inside of a star, but inside of a supernova is gold. And the reason they want you to look at your textbook, they want you to see what atomic numbers are greater than 26, and you'll see gold has a larger atomic number. So then as we go along here, okay, so we want to go to problem 2. So right here, we'll click on problem 2, and it's going to take us to a spiral galaxy. So based on how this is rotating, it looks like this star is rotating clockwise, right, to give us these spiral arms there. So let's see what the question is. And so looking at spiral arms from this viewpoint that we saw there, in what direction is the galaxy rotating? It's rotating clockwise. And continuing on here, to answer questions from this worksheet, go to the following Geo Tours, okay, Earth and Sky, double click on place mark. So now we want problem 3A here. So we want to go back to Saturn here and click on Earth, right? When we click on Earth, then we want to go to problem 3A. And this should take us to a crater. So that's one instruction. Yeah, there is a crater there. And so there's problem 3A, right? So we need to measure the size of this crater, right? So let's read the instructions for that. So using the ruler tool, use a ruler tool to determine the present day diameter of Manicalgan crater between the place marks, right? So that ruler tool is up here at the top. You click on that, right? And they wanted it in kilometers, right? Kilometers. And so let's move this out of the way up here, and we'll go, let's do it from the 2 place marks. Yeah, so if you do that, you get about 74 kilometers. And so, yeah, so that would be our answer there, 75 kilometers. So that's how you use the ruler tool. Now, question 5. In this case, you want to go to the folders of Google Earth, Explore Geo Tours, Earth. So same questions. And now you want to do 3B, and it's a dome here, upheaval dome. So let's go to 3. And there's upheaval dome right there, right? So, so use a ruler tool to determine the present day diameter of upheaval dome, and again in kilometers. So again, we'll use our ruler tool. We need to do it between the 2 place marks, between there and there. And that gives us 4.62 kilometers, which is pretty close to this first option, 5 kilometers. Then for question 6, again, we want to use a ruler tool to measure the diameter of meteor crater. That's in Arizona. So we want to do problem 3C. So we'll fly over to Arizona. And near Flagstaff is a meteor crater that occurred about 30,000 years ago. And so let's see what the question is here. We want to use the measure the diameter of this crater here. So again, using our ruler tool in kilometers, between the 2 place marks they have here, we get about 1.15 kilometers, and that's, well, that's probably this one right here, 1.2. Now, question 7, again, we want to go to problem 3D, and we want to measure Chesapeake Bay between the place marks. D. We fly over here to the East Coast, past Appalachians there, and there is Chesapeake Bay. And here we want to measure this distance between these two place marks here. So we put our ruler, put one point there and the other point out over here. And we have about 96 kilometers. And right there, 96 kilometers. And so you see how this works, right? Let's look at question 10 here. To answer these worksheets, we're going to look at some features of the ocean floor. And we want problems 4A through I on the East Coast of the United States. So let's look at that problem here. 4A. So here are the problems for A1, 2, and 3. And so these are features along the coastline. And I'll tell you right now that this wide region here is called the continental shelf. And then this sharp line here is a drop-off from the shallow shelf, which is usually less than 200 meters deep, to the deeper parts of the ocean here. And we usually call that the shelf break. But you can see that problem 4A2 is the continental shelf, whereas 4A3 is called the continental slope, and that slopes down to the deeper parts of the ocean. And then 4AI would be the deep ocean called the abyss. So let's take a look at what the questions are. Yeah, here it is. And then 4I is the abyss, that's correct there. And then III is a slope. So this is the correct one there, right? So that's what they want you to do there. And then if we look at 4B, identify the area depicted by the placement in near eastern Greenland. So let's see what 4B is here. So we'll go up here to Greenland. And oh, that's a continental shelf. You can see it's a shallow submerged edge of the continent. So remember, all this is still continental crust here. The ocean floor doesn't begin till out over here, right, along this kind of the base of the slope. So we're looking at the shelf, right? Let's take a look at question 12. And here they want us to look at problem 5A, I through 4 here. And we want to pick the incorrect answer. So here it says 5A, I is a deep trench, ocean trench. 2 is a seamount. 3 is a mid-oceanic ridge. 4 is another deep ocean trench. So let's take a look at these on Google Earth. 5I is an ocean trench, so that's correct. 5A2 is a seamount, right? So let's see what 5A2 that is. So these two are correct. Let's see what 5A3 is. 5A3 is what we call a fracture zone, And so a fracture zone is not a mid-oceanic ridge. So 5A3 would be incorrect. And then 5A4, see where it takes us over here to South America. Oh yeah, that is an ocean trench. That's a Peru-Chile trench. So of these, it looks like that would be incorrect there. Well, anyhow, you can see how we can work using Google Earth to solve some of these problems. So let's just submit the quiz here. First is correct. The second one is correct. The third one's correct. Correct on the fourth one. Correct on the fifth one. Correct on the sixth. Correct on the seventh. We didn't answer question 8 nor question 9. Correct on question 10. Correct on 11. And we were correct on 12. So anyways, let's stop here for now.